Good morning, everybody. I'm very excited to have you here, and I'm sure you'll enjoy and learn a lot from this class. To start with, on the right is our scheme of work. So make sure you write that down neatly in your notes. The first topic is formal geometry. Please make sure you write the date. Today's date is June 8th. And the topic is triangles and polygons. Formal geometry, triangles, and polygons. Triangles and polygons. And what's the first thing we are learning under that? That's the interior and exterior angles. Interior and exterior angles of triangles and polygons. Interior and exterior angles of triangles and polygons. Now, let's look at this theorem. Theorem 1. The sum of angles in a triangle is 180 degrees. Now, how do we prove that? Let's see. It's a triangle. Please make sure your diagrams are bold and well drawn. Yeah, bold and clear. Now, A, B, C, P, X. We want to show, let's call this angle B2 and this angle A2, this angle A1, this angle this angle C, and this angle B1. Now, we want to show that it is true that the sum of angles in a triangle is 180 degrees in any triangle. Now, this is how to go about the proof. Given any triangle ABC, that's what's given. To prove, this is what we want to do. We want to show that the sum of all of the angles inside triangle ABC is 180 degrees. Construction. This is the modification we are going to do of the diagram of triangle ABC. Construction. This is not part of triangle ABC, but we are adding it to triangle ABC. Produce line BC. Produce line BC to a point. Produce line BC to a point X. That means make line BC, longer. And that point where it stops is X. Now, what's the next thing we're going to do? Draw CP parallel to BA. That means draw another line from C to a point P such that it is parallel to BA, which is this. Of course, you can see that that's this line and it is parallel to line BA. Now we write down. For the next step, that yeah, so with the representations on the diagram, we can see that line. I'd like to bring this diagram down so that we can check it as we continue with it, as we do the proof. Let me paste it down here. So now with the representations on the diagram, you can see that A1 is equal to A2. Angle A1 is equal to angle A2. And I'm sure you can all remember that. The reason for that is because they are alternate angles. If you check that, I'm sure all of you know that angle A1 is equal to angle A2, since line BA is parallel to line CP. That simply means line AC is a transversal. So that's why angle A1 is equal to angle A2. Now angle B1 is also equal to angle B2. And the reason for that is because they are corresponding angles. You remember that from junior secondary school. Corresponding angles are equal. Angle B1 is equal to angle B2 because they are corresponding angles. Now that simply, we know that angle C plus A1 plus B1 is equal to 180 degrees. And the reason for that is because they are all on a straight line, angles on a straight line. Look at what I'm saying. This angle C plus angle A1 plus angle B1 is equal to 180 degrees because they are all on this straight line BCX. And we all know that angles on a straight line, the sum of angles on a straight line is 180 degrees. So if you add all of these together, C, A1, B1, you're going to get 180 degrees. So angles on a straight line. Angles on a straight line. On a straight line. You don't need to redraw this diagram. I've just brought it down for you to see. Don't redraw the diagram. And the diagram here is just for you to see what I'm writing as I continue with the probe, or to see the values, the part of the diagram I'm referring to as I continue with the probe. This is B. And that's supposed to be okay. Yeah, this is the diagram. Now let's continue. Therefore, if we say that C plus A1 plus B1 is equal to 180, that means C plus, then definitely C plus A2 plus B2 is also equal to 180 degrees. Why is that so? A1 and A2 are the same. B1 and B2 are also the same. So instead of writing A1, I can write A2, and instead of writing B1, I can write B2. And that's equal to 180 degrees. So now we have been able to show that. And of course, angle C, A2, angle C, angle A2, and angle B2 are all in triangle ABC. Of course, you can see them. Angle C, is inside triangle ABC. Angle A2 is inside triangle ABC, and angle B2 is also inside triangle ABC. And that's the end of our proof. We've been able to show now that the sum of angles inside any triangle is 180 degrees. So this therefore means angle ACB therefore angle C is actually ACB in the triangle. Angle ACB. Still need to paste that. Angle C is angle ACB plus angle A plus angle B, which is equal to 180 degrees. And that simply means A plus B, therefore A inside triangle ABC, therefore in triangle ABC in triangle ABC, angle A plus angle B, angle A which is A2 plus angle B which is B2 plus angle C which is small letter c is equal to 180 degrees. And that's a proof very, very simply. That's a proof very simply. So that means the sum of angles inside any triangle is 180 degrees. Now, what's our next theorem? Our second theorem. The next theorem is theorem 2. And that's about the exterior angle of a triangle. By the word exterior, you know it means outside. Exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of the opposite interior angles. The exterior angle of a triangle is equal to the sum of the opposite interior angles. That's a theorem. Now let's see how that was come about. Let's have a triangle ABC. Let's draw triangle ABC. Make sure your diagrams are bold and clear. Get a pencil and a ruler and an eraser. This is triangle ABC, and that point is X. This is angle A with triple marks, and this is angle C, while angle B rather, while this is angle C. Yeah, those marks are just to differentiate between the angles. Now, what are we given? Just in the same fashion, given any triangle ABC with BC produced to X. What do we want to prove? We want to prove that angle ACX is equal to angle A plus angle B. Now, here comes a proof. ACX plus ACB is equal to 180 degrees. Let's see that. As usual, I'll bring the diagram down so that I don't have to keep scrolling down. or scrolling up. Let me bring the diagram down. Don't redraw the diagram, just draw it once. This is just for us to see the labelings on it. Now, angle ACX, which is this, ACX, angle ACX, which is this, plus angle ACB, which is this. Let me represent that in purple. So this yellow angle plus this purple angle add up to give 180 degrees. And you all know the reason for that. Sum of angles on a straight line. Sum of angles on a straight line. So I'm going to write that. That's the reason here. Sum of angles on a straight line. Sum of angles on a straight line. That's the reason for that. Now, having said that, angle A plus angle B plus angle ACB is equal to 180 degrees. And what's the reason for that? Sum of angles in a triangle. Sum of angles. I'm writing this in short for angles. Sum of angles. Let me write that. Sum of angles in a triangle. This simply means triangle. Sum of angles in a triangle. ACB plus A plus B is 180 degrees. Sum of angles in a triangle. That's already proven, so we can use it here. We can just state it here. And what does that mean? I need to move this diagram down. I need to now. That's the diagram. Now that simply means we have said that ACB is A plus B, angle A plus angle B plus angle ACB inside triangle ABC is 180 degrees. That simply means angle A plus B. That simply means angle A plus B. Angle A plus angle B is equal to 180 minus angle ACB. Minus angle ACB. And we know that angle ACB from here we already said angle ACB plus angle, let me go back to that. We know that angle ACB plus angle ACX is 180 degrees. Did I get that right? ACX plus ACB, yes. ACB plus ACX. ACB from here. We can check this. We know that angle ACB plus angle ACX is 180 degrees. And that means ACB is the same as let me write this. This simply means angle A plus B is 180 minus ACB. But I think that's a better way to go about it. From the equation that says ACX plus ACB equals 180 degrees, I can say that ACX is equal to 180 minus ACB. Of course, you know why this is so. You know why? Yeah. You know the reason for that. Just move ACB to the right hand side. ACX is equal to 180 minus x degrees. And we have also shown that angle A plus angle B is equal to 180 degrees minus angle ACB. So you can see that these two things on the left hand side mean the same thing. ACX is the same as 180 degrees minus ACB, and angle A plus angle B is also the same as 180 degrees minus ACB. That simply means both of them are the same. Since they both represent the same thing, that means they are equal. Therefore, ACX is equal to angle A plus angle B. Angle ACX equals angle A plus angle B. I'm going to write that properly. And that's the proof, simply. That's the proof. Of course, you can see that ACX is the exterior angle of a triangle. Whenever you produce any of the sides of a triangle to form another angle, this is triangle, for example, ABC. If you extend the length BC, maybe to a point X, the angle so formed is called an exterior angle. If this is a triangle ABC, and you extend length BC, length BA, if you make length BA longer, the angle that is formed by doing that is called an exterior angle. And if you make length AC longer, the angle that's formed when you do that is called an exterior angle. So that's a proof simply for both the sum of angles in a triangle and the exterior angle of a triangle. So you know now that the sum of angles, you know how that, those, what's it called, theorems, where you know how to show that those claims are true now. And that's how they were come about. Now, let's go to, can we take another theorem now? Or maybe we should just take a few examples on what we've done so far and take the next theorem some other time. Go to another theorem in our next lesson. Let's see that. Let me look for a simple example on the few questions we have. A simple example on that proof. Okay, let's take a few examples just for us to understand the proof a little before we go to another theorem. The theorems better before we go to another theorem. Example 1. The angles in a triangle. The examples we are taking are going to be things having to do with the two theorems we have learned. The angles of a triangle. The angles of a triangle are x, 2x, and of course, a triangle has 3 angles inside it, and 3x. Find the value. I know some of you might find this too easy, but don't worry, we are going to get into much more serious things pretty soon. In degrees. Now, find the values of x in degrees. Let's solve that. Solution. Now, we can draw the triangle. Let's draw the triangle this way. Let's make this a triangle. Let's say it is triangle. Let me call it BCD this time. BCD. The angles inside it are x, 2x, or I want to put the 2x here, 2x and 3x. Now they said we should find the value of x. Angle A, the angle at B rather, there's no A in this triangle, it's triangle BCD. So angle B plus angle C plus angle D equals 180 degrees. Sum of angles in a triangle. That's a reason why that is so. And that means x, which is angle A, plus 3x, which is x, which is angle B rather, plus 3x, which is angle C, plus 2x equals 180 degrees. X plus 3x is 4x, plus 2x is 6x. That means 6x equals 180 degrees. And we divide both sides by 6 to get x. That means x equals 180 divided by 6 is 30 degrees. Therefore, x is 30 degrees. And that solves that. Let's take a second example. Example 2. Let me make that a question on exterior angle. Find the angles. Okay. Let's look for that. Can I find any question on that? Okay. I think we can take this. Let's see. Okay. Let me take, I really want to take something just very, very simple. Okay, let me just do this. Calculate the size. Calculate the size of the lettered angle. The size of calculate the size of angle Y in the diagram below. The diagram of figure below. Let's see what do we make that? Let's do this. Calculate the side of angle Y. Let me call that A, B, C, and Q this time. Finding the size of angle Y. If I make this 48 degrees, and I make this, or let me just make it 40 degrees, and make this 28 degrees, and this Y, no, let me make this 28 degrees. Yeah, let me make this 28 degrees. 28 degrees. And this Y. Yeah, that's better. Let me make that Y. Now, how do you find Y? Here we can see that Y is actually angle BCQ, and it's an exterior angle. First of all, you should always draw the diagram even when you solve a question. So let me draw, paste the diagram here. Now that's the diagram. This is A. Now we can see that BCQ, which represents angle 1, is an exterior angle. So first of all, I'd like to find this angle. Let me call it X. X plus 40 degrees in triangle ABC plus 20 degrees equals 180 degrees. And that means, what's the reason for that? Sum of angles in a triangle, or you can simply say angles in a triangle. And that means x plus 68 degrees equals 180 degrees. And that means x equals 180 degrees minus 68 degrees. And that's 112 degrees. How about correct? 180 minus 60 is 120, minus 80 is 112 degrees. That's correct. So now we can say that angle y equals x plus 40. Exterior angle, I'm going to write this in short, EXC dot short for exterior angle of a triangle, or let me say of triangle ABC. Exterior angle of triangle ABC. And you know what that means. The exterior angle of a triangle is equal to the sum of its two opposite interior angles. So that means y equals, what is x? 112 degrees plus 40 degrees. Yeah, that's correct. And that's 152 degrees. So that's the value of y simply. Yeah, I think this is where I'm going to stop for today. In our next class called helping, we learn another theorem, and then you have maybe find the interior angles of a regular. Okay, yeah, your homework today is going over all of these and learning the simple proofs of the two theorems, the proofs for the two theorems we have learned. Make sure you are able to do it yourself. You can go through your note and then try to do it yourself somewhere without checking your notes. I hope you enjoyed the class, and I would love to have you around in the next class. Thank you very much, and God bless.